Hello, everyone. We're going to present our final project, which is to make an interactive Braille learning application. So who's on our team? So I am Daniel McCormick. Alongside me are Cody Wood and Wenbo Yu. We're all Masters of Computer Science students in our first year. So just a bit of background. To start with, what is Braille? So Braille was invented by Louis Braille, and it's basically a method for reading text for those with sight loss challenges. It's a series of raised dots that, in different configurations, represent different letters and numbers and so on. And so you run your finger across the dots, and they're able to therefore read the letters and then understand what the text is saying. With modern technology, we have these things called refreshable Braille displays. And so these are little devices like this image in the corner here that connect to different devices like your phone, your tablet, your computer. And what they'll do is they'll actually display the text that's on the device and just represent it in Braille. So if it says like, hello, how are you doing on your messages app, it'll represent that using the Braille on the bottom. And you will be able to both read and also write in Braille using the buttons at the top. And you can scroll through the text and kind of, it'll update as you go. Another thing to be aware of is the app called Duolingo. It's important because it's sort of an inspiration for this project. So Duolingo is a free app to learn languages. So it teaches you how to read, how to write, how to speak, and also how to understand when somebody is speaking to you in that language. So for instance, you can learn French, Spanish, English, Italian, anything really. Duolingo does have some education for Braille, but it's only on their web app. And it's using 2D flashcards, so there's no kind of tactile sensation, which is really important to actually learning Braille. Another important thing to keep in mind is that Duolingo uses the concept of gamification to make learning interesting. And what this is providing lots of rewards, banners, and like leveling up and stuff like this. So it's all these important motivation factors to help people stay engaged and keep coming back and learning more. So what are some of the problems that we're trying to keep in mind for our project? To start with, only 10% of people with sight loss can read Braille. So within the population, that's only 1 in 10, which means that the illiteracy is unfortunately very high. However, Braille is very important. There's a study done that shows there's a very high correlation between Braille literacy and employment for those with sight loss. And so being able to understand Braille, being able to read it and write it is a very valuable skill that just not many people are actually getting the time and the opportunity to learn. And a lot of this is because it takes really specialized courses to learn Braille. Like CNIB runs some of these courses. But the paper is much bigger because the text is a lot larger because it's hard. You can't fit so many characters in Braille the same way. You need special teachers to actually educate the students. And so there's a lot of barriers in the way of actually learning Braille. And so there are some Braille apps out there to help learn, but this is a really interesting quote we found on one of the reviews for one of those Braille learning apps on the Google Play Store, where the individual is saying, I don't understand how I'm going to learn Braille with this app if I can't even see. And so this kind of hits the nail on the head in terms of the issue with these Braille learning apps, and even the Duolingo one. Is that all of these apps are on a 2D screen, like your computer screen or your phone screen. And Braille is a very tactile language. You actually have to feel it to really understand it, not just know what the dots are. You have to be able to read them using your finger. And so these apps currently just have a problem in that they don't support this tactile sensation. And so that's something that we're going to try to solve.
So for our objective, as Daniel have said, is to design a mobile application to teach reading as well as writing Braille. And we want to design this application for Android and iOS. And the main differentiator between our app and what is currently exists on the market is that our application will be able to connect to devices that have refreshable Braille display or specialized refreshable Braille display devices. And this will provide independence for the users to practice and learn Braille on their own without the assistance of others, using both tactile sensations as well as auditory feedback. And so one of the ways that you can use auditory feedback is to use voice commands rather than clicking buttons on a screen. So normally when we interact with a computer, we typically have buttons, input boxes for us to enter things, and we kind of intuitively know that when we see a box or a button, that it will lead us to a command to the computer. But in the case if they have trouble seeing, then really it doesn't matter what's being displayed. So using their voice, we're able to adapt this technology to use your voice to give the application feedback, and the application will also act like assistants and will ask you questions on what you want to accomplish or want to do, and give you those options. And based on those options, you can say, for example, go to the next lesson, can you repeat the current lesson, and then that will restart the lesson based on your needs. Reading Braille on the keys and say them out loud will give them the opportunity to practice feeling Braille physically on the Braille displays. So they can feel the display and then say the word out loud of what they think the Braille is, and that will act as a confirmation to if they have correctly read the Braille. Writing Braille is also can be practiced because this type of keyboard will typically include a Braille keyboard along with the display themselves. So they can then practice writing Braille using that keyboard, and that can be also verified through the voice feedback if they got it right or wrong. So now that we know some of the core features that we have to implement, we want to go into our project plan. So we have 3 phases for our project. And during phase 1, we want to do more research about exactly what's currently on the market, what's available, what we need to do to better innovate in this situation, or if there's existing technology or literature that might help us. Another thing is that I think as much research as we can do, sometimes we just have to go to the users to find what they need. So we want to verify what we theorize and what we currently have researched with actual users who might be using our product. And we want to make sure that what we thought is correct is correct. And then from this point on, we'll want to create a low fidelity prototype to test the usability of this application, whether through interactive paper prototypes with another person that will literally say what the app might say from a script. And then one of the last things that we want to do in phase 1 is make sure once we have verified all these things, we want to start developing actual lesson plans that can be used later on. During our phase 2 of our project plan, we want to start actually developing a minimal viable product for our actual application that's actually in its intended target device, such as iOS, Android, and hopefully desktop applications as well. We'll be also implementing and testing our core technologies such as voice recognition, Braille input, Braille input system, all that bridging technologies. And then using these technologies, we'll build out and test our core feature sets that will be used for the lessons. Then finally, we want to do a public testing with a closed beta. So I know this is public and then closed. What we meant is that we want to do a closed beta with a public audience that's aside from our developers. So we'll be finding a group of our target audience, and then we'll have a closed beta test with those people specifically. Lastly, moving on to phase 3, what we'll be doing is that this is our actual public release for everyone, and this is going to be version 1.0. We'll adjust any features or any lesson plans based on our user metrics and feedbacks, hopefully on a weekly basis, and as well as continuous plan development. Lastly, for the implementation plan, we want to make sure that we're going to be developing this as a cross-platform framework, such as React.js. And then we'll be using Braille to communicate between the displays and current technology, such as your computer and laptop.
So now we're going to go over our SWOT analysis for our project. This will basically kind of reiterate all the points that we kind of mentioned before and give a better understanding of where our project lies in the market. First off, I'm going to talk about the positioning of the project. We're kind of positioning this project towards Braille literacy. The literacy rate of Braille is rather low in the vision impaired community. We'd also like this to be a very independent learning experience, allowing the users to learn by themselves without the aid of a tutor or another person. The target audience that we're going for are the visually impaired, um, as well as the people who have access or can get access to refreshable Braille displays. So for some of our strengths, the app will allow for independent learning and interactivity. It also allows for progressive learning, meaning the level of difficulty will increase as you progress further in your studies. The app will also be kind of personalized, so the pace at which people learn are kind of different. So the app will recognize the pace of the user that is currently trying to learn Braille and adjust to personalize the learning plan to that user. We're also trying to use a proven learning method, sort of what Duolingo uses, and how they teach different languages to people, but we're kind of changing that into a more interactive format using a more tactile method of learning. We're also a group composed of experienced interactive software developers who have worked with video games, websites, and other serious games using different forms of hardware. This kind of gives us the knowledge to create a friendly user interactive application. So one of our biggest weaknesses is that Braille displays and keyboards are very expensive. And one of the most popular ones is called the Brilliant Braille display developed by HumanWare. This display starts at a price of $1,000 and is only for a 14-character display. But if you want a more usable or high-tech one, you can get a 40 to 50 character display for around $8,000 to $9,000. And given this high price range, it kind of limits our barrier to entry as people don't really want to spend that much money on a keyboard, or people might not even be able to afford that much. Our other weakness is that we don't really have a lot of experience in creating a learning plan or learning materials, so it'd be best if we talk to an expert in the field to help us, and it might be beneficial in helping us make one for this app. So some opportunities that we have though, given our biggest weakness, we could actually potentially develop a Braille display or keyboard that is low cost. Given the amount of resources that are out there, we could potentially use 3D printing, open source materials, or even prototyping devices to help us potentially develop one. Also another opportunity is that we've kind of looked around and there aren't any apps out there that we know of that uses a Braille keyboard in the way that we want to use it, or any app at all actually that uses a Braille keyboard. We would also like to make this an open source platform. So given that the opportunity to do this, we could potentially have people from the community develop their own learning plans or learning materials so that when they're trying to teach other people or even upload new materials, they can upload it directly because it's open source, create their own, and allow other people to use that instead, so we don't have to necessarily make everything, but allow other people to do it themselves and have this sort of satisfaction and sort of community with it. There is also the potential to create printed lesson plans. So instead of having this tactile device, if we have people who don't necessarily want to buy a keyboard or can't afford the keyboard, we have the opportunity of creating a printed out lesson plan that will be printed on Braille paper. So you can still teach people the same method with an audio cue as well as this tactile interactive learning process. And lastly, for our threats, sort of like we said before, that Braille devices are very expensive, so it's still a threat to us in general, as well as only 3% of CNAB clients actually use Braille displays, so there's kind of a bad adoption rate. So the amount of people that we might be able to get into this could be pretty low. So that's it for our presentation. Before we open up to the questions, we just wanted to acknowledge and thank Dr. Mahadeo Sukai for consulting us and giving his time to really flesh out our ideas and get down to the nitty-gritty of which ideas of ours were good and bad and sort of why they were good and bad, and sort of give us a direction in which to go into. So here are our references, and again, thank you for listening, and we'll take any questions that you guys might have.